Assalamualaikum everyone. Today me and my partner are going to present our assignment 2. My name is Fatin Nadira binti Arsil and my partner's name is Suhashini anak perempuan Krishnan. So we selected piston crankshaft as our components. In this presentation, we are going to use two types of simulation, which are the thermal analysis and the static analysis. So this is our assembly video for piston crankshaft. So next, I'm going to present the manufacturing process. So in this slide, we choose piston head and connecting rod. So the first step to produce the piston head is a solid aluminium rod was cut into smaller pieces called slugs. Then the slug moves to an oven with heating 426 degrees Celsius as the punch press. Then the slug is placed to the punch and the press applies 2000 tons of pressure, fogging it into basic shape of piston. Then after fogging cools down, they go through oven twice more. The first time is at higher temperature to strengthen the metal. The second time is at a lower temperature to stabilize it. Then the large hole is then drilled through both sides of piston. This is where the wrist pin will go, attaching piston to the connecting rod. The three ring grooves are created by the lathe machine. Then in the last step, another lathe shaves a few more millimeters of the top to allow the piston to expand when heat builds up inside it. The sharp edges was smoothed out. To allow the wrist pin fit comfortably, they are put into a machine to smooth them and the pistons was sprayed by hot deionized water to remove any lubricant or oil.
Okay, let's look at the second component, which is connecting rod. The connecting rod can be manufactured through hot forging. As the first step, the rods are cut in proper size from billet and the length by using bandsaw or billet shear machine. Step 2, heating of billet into oil fire furnace up to 3 forging temperature ranges. Example from 1240 degrees Celsius until 1270 degrees Celsius and approximately 15 different ranges of temperature. Step 3, placing billet in between upper and lower die using tongue and completing forging in two stages. Example, forging, rolling and finishing. Step 4, visual inspection is carried out after completing of forging. For this stimulation part, we selected those four components which are connecting rod cap, piston head and piston pin. In this slide, we have demonstrated the assembly video for those components.
Next, I'm going to explain the thermal analysis. Thermal analysis is used for boundary condition for the analysis of thermal stress. It is also calculates the temperature distribution in a body. So first step, we select the thermal and then we define the materials. For the piston head and the piston pin, we use the aluminum alloy, while the piston rod cap and the connecting rod we use the grey cast iron material. Okay, next we define the temperature, which is 270 degrees Celsius, and we selected the face of piston head and the face of piston rod cap. Then we define the heat flux. We put the value 5 watts per meter square, and the entities we selected: the face of piston rod cap, piston, excuse me, connecting rod, the face of connecting rod and the piston rod cap. Next, we define the mesh. We take the fine mesh. So this is the result from the meshing part. Then after we run the analysis, this is the result of the thermal analysis. The results shows the calculation of temperature distribution in a body of assembled piston and the connecting rod. So here is the result of the thermal analysis. So the minimum temperature is 5.432 exponent to the power of 2 Kelvin, while the maximum temperature is 1.594 exponent to the power of 8 Kelvin.
Alright, now let's look at the following step to conduct static analysis using pressure as external loads. First step is from the assemble model, click to stimulation. Then click to the new study, followed by accept the static for stimulation. Second step is applying material for each and every component. So I choose aluminium alloy for piston head and pin, and grey cast iron for connecting rod and connecting rod cap. Third step is adding fixture. Here I selected the faces are chosen as the fixed geometry. Fourth step is adding external loads. The red arrow showing the direction of applied pressure. Here I selected pressure value of 10 megapascal to conduct stimulation. Fifth step is to create mesh, and this is the outcome for the mesh, followed by to run stimulation study. As the outcome of the analysis, we will obtain three types of the result. First, stress. Second result for the displacement. Third result for the strain. Let's watch the motion of the static stimulation. It shows the deformation shape once apply the pressure. The first result is for stress. Here it shows the deformation take over for the stress, and the maximum stress value is 7.258 megapascal and the minimum is 0 megapascal. The overall deformation scale for this component is 13.4299. Then this is the result for displacement. The maximum value obtained is 1.839 mm. And the last result is for stress. So the maximum value influence is 7.497. That's all from us. Thank you.